Okay, 8:35. I guess we can get started. Welcome back, everybody, from spring break, and welcome to week 4 of the Intro to Android course. Today we'll be going over the MVVM model view model structure, which is very important for building like real Android apps that have real functionality. Before getting into the week's content, quick announcements. You probably saw this already. Hopefully you did, because this is pertinent to today. But A3's deadline was extended to be due tomorrow as opposed to yesterday. Um, all the other assignment deadlines are remaining the same. This is just because like it was due during spring break, which is weird. But so yeah, that's 2-day extension, and now A4 is released, or at least like A4 for this week is something that you'll want to be doing, want to have done by the end of this week, since it's week 4. And that's on MVVM, so that's for like this lecture, just as a heads up. Okay, so for the itinerary, we'll be going over again MVVM, that architecture, what it is, and why it's important, or like why you should maybe choose to structure your app like this. We'll then go into the VM part of that, the view models, how to use view models as like a state provider for your UI. And finally, we'll be going over flows, which is sort of like the data structure that you'll use to actually transmit data from layer to layer downstream, it's called, between different layers in the MVVM architecture. So first starting off into an intro to MVVM. So as a bit of like a motivation for what MVVM is and why you might want to use it, let's kind of recap so far like what we've learned in this class like so far. So our lectures so far have been going over Kotlin, like basic UI, states, components, lazy column, navigation, and animations. You'll notice that all of these lectures so far have to do with like UI, just basically showing stuff or showing stuff in a pretty way. And so the idea, I guess, is that if, say you're working on like an actual app, and you had like a design team to make screens for you to make them look pretty. If you had a screen design given to you by a designer, uh, more or less from these first 3 lectures, you should be able to make more or less any screen design that a designer has given you. But an app needs a lot more than just like sort of placed UI to function as a real app. And certainly then you'll need stuff like app logic, which is very general, but that encompasses things like networking calls, which is very important to building like a real app that does stuff. You'll also need sometimes things like saving data to local storage on the phone. And the best way to structure an app with actual functionalities like these is, in our opinion anyways, MVVM. So with that in mind, I guess in terms of course structure, lectures 1, 2, and 3 kind of are the first half of the course, which is like Android UI. And with this, weeks 4, 5, and 6, we'll be going over MVVM, how to use MVVM and structure it in order to build like an actual full Android app. So basically, MVVM splits your Android app into 3 different parts. These are like the 3 components of your entire app. Um, and I'd probably go over them one by one. So you've got the model, the view model, and the view structured in this sort of like order. First, your view, which is something that you've already been familiar with. We're basically just calling the UI the view now. This is more or less what you've been learning the past 3 lectures. These are things like your screens, your components, what is actually shown to the user, which again is what weeks 1, 2, and 3 have been focusing on, how to like build your actual UI and your screens. Second, the layer above the view is the view model. And the view models contain all of the sort of state data and handle like state data very elegantly that a screen might want to know in order to like show the right stuff to the user. So we'll go over what that means in a second. And finally, your model will handle stuff like networking and local storage, which start going into how to make the actual networking calls to like reach a backend server, for example. And it's nice to have that separate from the view model, since those functions of like fetching things on like a from like a backend server are quite complex on their own, and therefore it's very sort of convenient to separate that into its own like organizational unit. If you see these little arrows here for the MVVM architecture, you'll see that these layers have to communicate with each other, obviously. And in terms of those arrow connections, you'll see that they only really exist between model and view model, but vice versa, and the view model to the view. So first off, the view model will communicate to the view by giving your screen, basically telling what the screen, giving the screen the correct data to show, and the UI, whenever the user interacts with the screen, say presses a button or whatnot, will tell the view model that a user pressed a button or something like that. And the same thing, same sort of relationship happens for the view model to the model, which we'll go over more in week 6, I believe, where the view model will query the model for things like networking requests. And then once those networking requests are done, once they've resolved, the view model will receive them from the model afterwards. As a bit of a side note, not that important, the model and the UI should never directly communicate. It's like bad practice. And so more or less the view should only really get stuff from the view model, which might require you to like write extra code at some points, but just for practice and like maintaining the structure, this is a generally bad idea. Okay, so all together, once you like use all this and once we learn how to use MVVM like completely and how to code it and whatnot, this allows you to, or it's like sort of MVVM in general is like one option that provides a really solid structure to for how to build a app with like real functionality. This is what we use on app dev, and it's also used on teams like Meta and Robinhood, so probably has some good merit. Okay, so now that's sort of the breakdown of the idea of MVVM, and now we can go into like the view model portion of it. So for view models, the idea of view models is that they have two purposes. The first one being that, again, well, I guess if you remember the fact that there's a double connection between the view model and the view, this is sort of the downward connection. So the view models, like one of the view model's purposes is to provide the UI, the screen state. And so this is sort of a recap that the screen state or like the state of a screen consists of all of the dynamic data that varies from a screen and use to use. As opposed to static, like hard-coded data that won't change no matter how many times you navigate to that screen. So on this chat screen, for example, in Resell, what is the dynamic data? Well, that's things like the seller's name up there, the item that's being bought, the name of that item anyways, the chat messages, the profile picture, stuff like that, the things that would be able to change between chat to chat or as the user is interacting with the screen more or like the information that is displayed would have to change. And so for all of these like dynamic pieces of data that the screen doesn't know like automatically what has to be displayed, the view model in this case has the job of telling the UI what to show in each of these cases. And so on the other hand, just for example, I suppose, what is not dynamic data, what will not change, are things like the arrow icon, like literally the icon that you're using, that will always be that icon. And so the view model doesn't have to provide those things and so on. And before, I guess, in general, you would put these things in the UI. You would just sort of leave these states hanging around in the UI. But now we'll want to pull out these pieces of data into the view model instead, the general idea. Okay, and the other purpose of the view model, the second purpose of the view model, and this is again like the upwards connection, is to listen to the UI for like user input events. And to handle them accordingly, aka do the right thing whenever the user does something on the screen, interacts with it in some way. And so in other words, the view model will define what happens whenever like a button is pressed or text is typed in, any sort of user interaction, whenever any sort of user interaction occurs. I guess the key idea is for this direction is that like from like an abstraction perspective, if you know that term from 2110, the idea is that the view does not know what the buttons do or what any of its functionalities do, even if it seems intuitive. The view will simply just tell the view model that something happened. So for example, the view will just simply tell the view model that a button is pressed. The view doesn't know what that button is supposed to do at all. All it will do is notify the view model that, oh, the button was pressed, you should do something about it. And then the view model, you'll define the functionality in the view model for what to do in response to that action being pressed. And so I guess in this example, if the user were to press one of these knobs on the bottom, the screen will fire like an on click in the UI. And then simply in your screen, instead of like implementing that on click to be like complex, actually do some logic, it'll just be one line that tells the view model like, oh, the on click fired, do something. And so that would be like um, chat screen view model dot on knob pressed or whatever, something like that. It would just call a new function in the view model, and then that function in the view model would actually tell you what to do. Um, and these are just examples of what user inputs the UI might want to notify. So for example, if you press pretty much any of these buttons, then you would just tell the view model that that button was pressed without wondering about like what that button is supposed to do. And so, as just a bit of a recap as to how these two pieces, or I guess three, if you count the user screen, like what the user is actually seeing as like sort of a recap. So in the sort of downward direction, at every point in the app lifecycle, the view model will tell. I guess that should be the view. It'll tell the view model will tell the view give the view all of the state that it needs to determine like what state the screen is, like sort of all of the data that the screen needs to show. And then the UI, if you've implemented correctly, will actually display to the user the correct screen given that state data. And then on the other direction, say that the user is interacting with the screen. Whenever the user like presses on a button, that will fire an on click in the view, which then all you have to do in the screen is to just tell the view model essentially that the input has occurred. And then in the view model, it'll handle the on click correctly because that will often deal with like pretty complex logic that you want to handle instead in the view model to organize things cleanly. Okay. Any questions on any of that? Like the idea of MVVM or how these, at least these two layers so far, interact with each other? Any questions? And I can look on Zoom for any questions as well. But if not, then we'll move forward with flows. So flows are kind of how you like implement the downward direction between the view model and the view. So that will look like, I guess here's just like a recap of how these layers interact. So on the upward direction, you have like if the user presses a button, the view will notify the view model that, oh, some input occurred. I'll just fire like this on-click function and tell the view model that something happened. But in the downward direction, the view model has to sort of constantly update the screen for what state the screen is in, aka what data it should be showing. And so while the first top one is something that we've sort of seen before with just like Lambda functions on click, the second one, the one on the bottom, is a little bit more like a little bit more new, a little bit more alien. And so in that case, we'll need a new sort of like data structure called flows in order to handle that downward data like the sending of the downward data between the view model and the view. And later on, you'll also see the model to the view model. So the flow again is like a data type in Kotlin. It's like a data structure in some sense. And its job is to send data of some sort of like generic type. This can be any type and often a custom class that you make down from like a provider to a collector. In this case, the provider would be like the view model, the collector would be the view. And again, the T here is like a generic type. And so you can, if you want to code your flow, you can make it send any type of data down. And so this can be like an int string, or oftentimes best practice is to make your own custom class that bundles a lot of information together and then send it all at once in one flow. Here's some notes about flows. I'll sort of explain these one by one, but these are kind of things that you would just like pick up by coding it, if that makes sense, like working with examples. But nonetheless, I'll go over these one by one. So First thing is that data can only move like upstream to downstream. And so the view model will just be providing data to the screen. The screen doesn't use that same flow to like send data upwards. That's not possible. More or less, the idea of a flow is that the view model just sort of sends information only to the view and not vice versa at all. And so the flows are not at all used for the view to send information upwards. It's only sort of the downwards direction. Second note is, and this is pretty important, but again, it's sort of something that you'll get just by like working with the flow more and like with working with flows more and like view models and views, you'll get to understand this more conceptually. But each flow only emits like one data packet or one important data packet at a time, and so um, only like the newest data packet that's sent down and like being read should be considered valid, and all the other previous ones are like not useful whatsoever. And so, in other words, the view only has to care about like the most recent uh, piece of information, the most recent data packet or whatever that's being sent from the provider, and all of like the previous ones that are sent before it do not matter at all. And so, the idea is, for example, if you wanted to send like a list of chat messages that the user or that the screen is supposed to show, you would send a flow of list of chat messages as opposed to a flow of chat messages. If that makes sense, again, this seems kind of confusing. We'll get into this in a little bit. But if you were to send a flow of chat message, for example, it would only have like one or represent one valid chat message at a time, versus a flow of list of chat messages would say, whenever I emit a list of chat messages, that list consists of all of the data that the screen needs at one particular point in time. And we'll see the distinction in the code example in a bit. And so finally, this is probably the most important part for how to like conceptually, or not conceptually, but more like directly use this in your code. A flow can be converted into a state to allow UI recomposition, which makes it very easy to use flows like in your UI, since ultimately state is what Jetpack Compose will always need in order to cause recompositions and cause the screen to re-render. And so you'll need to convert it to a state in your UI in order to allow recomposition and have the screen work correctly. Okay, so here's just some code examples, and we'll get into more like practical slash integrated examples in a second. But here's how you make a flow. So to declare a new flow in Kotlin in your view model or your model, you can just use this syntax. Mutable state flow is essentially the class, and this is a constructor that just takes in the initial value and then creates the flow. So for here in this first code snippet, the seller name flow will become like a flow parameterized on strings. So it'll emit string values. And the initial value here, the first value that is sent down the flow is initial value. The string initial value, dot, dot, dot. Optionally, you'll probably see code examples have this, but you don't really need to do this. But it's a good like code practice thing to do. There's something as opposed to like mutable state flow, something called just a state flow, which is read only. So you can have like inside of your view model, this all is inside of the view model, by the way. Inside of your view model, you can have like a private function or private field just for like the mutable state flow. So the view model can change things internally, but then you'd expose only the like state flow so that the screen doesn't accidentally send anything down the flow or like change anything. This is again not a big deal, but this like reinforces that the flow is like read only to the view and basically just makes it so that like you don't accidentally violate like abstraction stuff. And then here's like to use a mutable state flow is very simple. So again, this is purely for the view model. To send data down a flow, you'll just use the dot value like field to set like what the most recent value of that flow is. So you just say dot value equals new seller name, and then just by calling that one line, that new string, new seller name will be sent down seller name flow and automatically update the UI. As long as you do what's on the next slide. And so if in the view model you actually want to read the flow value, like the most recent slash like the valid flow value, you can just also use dot value to read. So you can use the same dot value to read or write when you're in the view model. And perhaps most importantly, to get this working with Jetpack Compose in the UI, you'll have to call this function here. So recall that we have to convert this to a state. We have to basically convert the flow to a state to get it to recompose with Jetpack Compose, since Jetpack Compose always uses that state class to get things to like re-render. So to do that, you just call this dot collect as state function here. Dot collect as state will convert that flow from I believe like a state flow to a state, like a read-only state. And so my seller state here, for example, since you called it on seller name flow, which was a flow or like a mutable state flow of type string, we'll convert it to a state of string. And the idea is that now whenever a new value is sent down seller name flow from the view model to the view, it will now update to the new seller name that's provided by the flow whenever it collects a new value. So my seller state in effect will cause the UI to like constantly re-update to the newest name that is sent down the flow from the view model. And that would hold true for whatever flows you have in the view model. Let's see. Oh yeah, so a quick note on like best practices before we get into a code example, or like a actual project, which is like the lecture demo. A quick note is that best practice for the sort of for the data packet that's being sent down, the each flow can only send like one object at a time, as I said before. And so for example, as like a bit of an aside, if you wanted to send a list of data all at once, you'd have to say flow of list of t, like that t value that you want to send a lot of. And sending flow of t basically only makes it so one valid or one value is valid at a time. But the idea is, of course, that screens need a lot of data all at once. Usually don't just need like one string value or even one list of string values. You'll need like a lot of different information across a bunch of different types for view models. And so you could make a bunch of different flows for each one of these different basically all of these different like pieces of information, but that would cause a lot of clutter if you were to write one flow for each like variable or field that you need to pass down. So instead, you can make this like custom data class for every like view model that you have that will like very neatly pack together all of the different pieces of information that the screen needs from the view model to display all of its stuff. So if I was making a chat screen, I could make this like chat UI state that basically defines or like packages together all of the different information that that screen would need. And so it's like seller name, item name, the message I've currently typed in, stuff like that, all bundled together. And then my mutable state flow, I can send instances of this like custom class down so that it's all packaged nicely together. And this is definitely more organized than making like a bunch of different flows, each like one for the seller name, one for the item name, one for the type message, and so on. You just make one flow that the screen reads from, and that's it. Okay. Any questions on that now with like flows, how they work, or how they like are conceptually like syntactically working, anything like that? Any questions? I'll wait for a second for anything from Zoom, but if not, the next thing we have is just like a relatively quick code example, but we'll probably like spend a good amount of time, more or less to the end of lecture, just like diving through that. So if you don't have any questions, or even if you do, hopefully this code example will break it down a little better for you. So apologies, I'll probably need like a very quick second to set this up, but I currently have my actual phone here running. Yeah, wonderful background photo I have. Okay, so I created like a very mock like bank history app. So here you can see, I'll just full screen this. Forgot which button that is. I think it's this one. So the general idea is that we have like a very simple bank history app here. But what makes this at least somewhat cool is that these transactions are like constantly updating in the background in real time, and I have a refresh button here. So if I click refresh, it'll swap over to this like loading screen, which is a pretty common thing you'll want to make in many apps, like a loading screen or like loading states of some sort. And then the new ones will load in. So if I go here, scroll, this is definitely a lot more than I had before, and I made it so that it constantly spawns them every 2 seconds. So you can see here the seconds go from 21, 19, 17, like over here, you can see. So in that case, and again, whenever I hit refresh, so the first one that appears here is 21 or like 21 seconds. If I refresh, 49 seconds, and all of these new ones have appeared since 21. So this is like relatively complex logic that will take like actual like mock backend networking calls in the background, as well as like different like states that the UI could be in order to like accomplish. And so it would be pretty difficult to code all of this in just like states within your UI. And so what is definitely very helpful is like using view models as a structure to organize all of this in order to make creating an app like this much more feasible. So let's see. I don't have that much of like a keen structure on how to do this or how to show this, but at least I do have like one to do after going over the general idea of how this is structured that shows how this works. Let me pull this back up on the side here. Okay. So the general idea here is that in my bank history screen, I have a very corresponding bank history view model class. And so if I just take a look over at the screen here, so the screen has a corresponding bank history view model class that basically just defines the view model for this one screen. And every screen will have its own like different view model class. And so like don't worry too much about like Hild view model. It's basically just a third-party library for MVVM, but it'll make the view model. And then you can see here that from the view model, I have this UI state flow that I am converting to a state with collect as state to get this UI state. And then just passing down into this like screen content composable. This is just a like organization thing. I could literally just like copy all of this and put it here instead. It's just a code organization thing such that if I wanted to preview like the screen content with one UI state, I could just add like an app preview here. Or like app preview and then send us thing down the screen content. As like a bit of like a semantic, you can't really preview with a view model since the previews like don't have a view model in their life cycle. So again, don't worry too much about this. It's just like a code organization thing. But again, once the UI state is like received by the screen, it'll render like the screen content accordingly. And so it'll have things like, oh, the username that's given by the UI state is shown here. I've put that as Markiplier. Don't worry much why, but you can see here in the view model, like the initial state I put here is that, and so the screen here is depending on the view model to tell it what the username is, and so we have a couple of other things like that, such as it's maybe arguable whether or not I should have done it like this, but. Actually, no, that seems reasonable. So I have like a very simple animation here. You can see whenever I press refresh. So whenever I hit refresh, you'll see that like there's like this animated content that's like swapping it in and out. It's not just like appearing or disappearing. And that's basically just what's happening here. So whenever like a new screen is to be shown, which is represented by the fact that the UI state has changed, I just have a very simple screen here that says whenever, or a very simple animated content here that says like whenever the screen changes, if it's loading, it should go to this loading screen here, which is loading content. Otherwise, actually show the stuff, right? If you're curious, this is very briefly what the loading content looks like. So it's just like a little thing with the circular progress indicator. That's that little spinny thing, and then some spacers. Don't worry too much about how that works. And then the actual loaded content will use like a lazy column to show all of these different recent transactions. Okay, so like the screen itself is pretty simple, and the screen is like things that you have seen in like lectures 1, 2, and 3. But what is definitely more like complex is the logic that's happening in the background to get all of this like transaction stuff working, which is being handled again by the view model instead. And I guess one final thing to note is that the view model is also telling the screen what like all of the transactions that it should be showing. And so it's giving every single like title, date, amount, such as like Best Buy, the date, time here, and the amount. I guess you got a paycheck from Best Buy, that the screen should be showing, so that the screen doesn't have to do any complex like computations or anything like that. The UI state also, for example, just gets the balance text from the UI instead of like, oh, reading all the transactions and computing the balance itself. Anything that is like even remotely complex computations or like any computation at all should be done just in the view model and then just given very plainly and easily to the UI, so that the UI in its like really complex, like composable recomposition lifecycle stuff doesn't have to care about any of that. And it just displays the right stuff, if that makes sense. Any question about the UI here before we go over to the view model? I'll wait for a second for any Zoom questions as well. But if not, we can hop over to the view model as well. So the view model here is sort of what does the actual heavy lifting in terms of like telling the screen what to show, and doing any app logic in the background that allows for like this refresh stuff, as well as pulling things from like this fake backend that we have that's like showing all the transactions. So um, let's see. I guess to start, we can take a look at this UI state class here. So remember before how I said that the flow, like a good general practice for your flows is to have this like UI state class that bundles all of the screen information all together in one in order to have the like completely encompass all of the information that's being shown in the screen, so that you only need one flow to transmit all of it. Well, that's this class right here. And you can see that I'll break down the syntax here since it's pretty useful. You'll see here that we have only three fields: username, which is a string; transaction, which is a list of expenses. The expense class is just here. It's very simple, just title, date, and amount. And so it's a list of expenses that basically is all the transactions here. And the loading, which is just literally just a Boolean that says, okay, did I hit refresh and should I be doing this or not? And so you can imagine if I was the if I was the UI, I could just look at the loading Boolean here, for example, to show like, oh, if loading is true, then I should show this spinny thing. If loading then turns false, then I should be showing this screen instead with the transactions here. Okay, you might be wondering what all of these are. These are, I'm not actually sure what the exact name of these are, but it's like a derived field or something like that, where in order to make like construct a UI state, the only thing you need are these three values here. But if you ever want to do any like useful computation with those values, such as sum the balance to 7,085.21 cents, with like the things that have been passed in, you can do that with these like derived values here. So so like, for example, the balance is something that we can calculate with the transactions by just summing up all of the expenses within the transactions. So we can use like this derived value to say, okay, we're going to provide the ability for the screen to get a balance. But then whenever the UI like would want to get that balance, we actually just compute it in the background by like summing up all of those transactions, and then I just put like a plus 500 so that they don't go like broke most of the time. But this get here is basically saying that the computed value of balance is like purely dependent on like the transactions that we put in. Like theoretically, I could put in like a val balance here, and then it would just be like my responsibility to make sure that that balance is always maintained. Or if it just purely depends on like another value that's being shown here, I can just like use this syntax to again compute that very easily and have like a new field nonetheless that the screen can use very nicely and easily to get like the balance of this account, for example. Same thing for the color. So I've defined just as an example that, oh, if the most recent transaction is negative, then I want my balance to be like the balance up there to be positive, or for example, if I've just oh, I think that's actually supposed to be transactions dot get like the last one. But the general idea is that wow, there are a lot in here. I think this was supposed to be the last index actually, as opposed to the first one. But the general idea is that, oh, if I wanted the balance color to also depend on some other state that or some other value that I'm passing in, I could compute it here to be like, oh, if the first transaction is positive, then I'll want that to be green, otherwise red, something like that. And finally, um, uh, I'm not actually sure if I'm using balance because I also have this balance text that like takes balance and then nicely formats it with like a dollar sign, for example. So that again, the screen literally has to do nothing. The UI does absolutely zero computation. We're making it like as easy as possible for the screen to use this information to like show the balance literally just by using balance text, as opposed to like having to do any of this computation on its own. So you could, I think you remember in A3, or if you're doing A3, that you have to do stuff like this. And you'll often have to kind of awkwardly put this in the middle of your code in order to get like computations and stuff to run. The idea, certainly with the view model, is that the view model handles like any and all of those complex computations so that the UI has to do like nothing for computation. It just listens blindly to whatever the view model tells it to display and then just displays that. So theoretically, if I were to make the balance text like just like something, or I guess like theoretically, if I told the screen to just display like absolutely nonsense, uh then the screen would actually start showing that, right? Since the screen sort of just blindly listens to the view model to tell it what to display. So the screen, even though it's implemented correctly, it says that, oh, my balance or my text here should be showing the balance text. If I don't implement that correctly in the view model and just like display something that makes no sense, then the screen will just show that, right? I do that just to sort of get home the point that um, that the screen here will just like trust the view model to or to like tell it what is the correct information to display. The view model is in charge of doing that sort of computation in the background, but otherwise the screen will just sort of blindly show that information. Okay, and so apart from that, I have like the UI state flow that basically just sends down like instances of this UI state. So like little packages of all this data, it'll send over to the screen. And then I have this UI state flow here, which is the same UI state that I'm reading here. So if I go to the definition of that, you can see that this is like the UI state flow that the screen is reading from. So let's see. So one pretty cool piece of like app logic here that's maybe like the only cool, like really cool piece of app logic here in the screen, in this view model, is this on refresh function. So that basically is what is called when I hit refresh here, right? So to quickly see where this is being called, let's go back into the UI for a second. So the screen content here has like an on refresh, right? So if we go down to the button here, basically what this button does, you can see here, oh, you can't really see this refresh button. That's my bad. This thing's blocking it. Whenever I click refresh here, you'll see here that the onClick literally just calls this Lambda function on refresh and like nothing else. So like the onClick here doesn't tell the view model, oh, you should convert the screen to loading, you should hide the transactions, you should do this, this, and that. All it will do is just tell the view model, oh, I called on refresh, or like I pressed the refresh button. The screen, again, like we want to make the screen essentially as dumb as possible, if that makes sense. We don't want the screen to try to do any of its like update logic on its own. All it will do is tell the view model, we're going to call basically on refresh here to tell the view model that, oh, the refresh button was pressed. You should probably do something important, do something about it because this seems kind of important. And so that's basically what this on refresh button does. And if we had any other buttons, we would have like an on click for each one of those buttons defined in the view model. And so this is like a little bit weird syntax. We can break it down a bit step by step. We have like a good amount of time. So basically, whenever we call like refresh, whenever the refresh button is pressed, we will tell the screen that you should show the user that it's loading. this networking call here, get transactions. This goes into like week 6, like how to use like coroutines and how like networking stuff works when especially when they take a little while to compute. But you can see here that get transactions is what is called a suspend function. Um, this means that it might take a while for the function to terminate, like to actually give its result. And so this line of code here might take a few seconds. And that's why whenever I hit refresh, it'll actually wait here for a little bit. And so whenever line 62 here is done computing, it will, or line 62 will take a few seconds to compute. And then after that, lines 65 and so on, like this stuff will fire afterwards. So after the get transactions is done, which again might take a few seconds, then like assuming that that line completed correctly, we'll just say that, oh, okay, the networking is completed. We got the transactions from that call, and we'll pass that over to the screen. And as like a final little bit, the view model will tell the screen, like, oh, we're not loading anymore. We have successfully actually loaded the transactions. And therefore you don't need to like show the loading anymore. You can just say that like we're done loading and to give them those new transactions. This dot copy thing here is useful because um, for example, I don't need to keep changing the username every single time. So like the username will be the same, the username markiplier, and in this case, will be the same regardless. And so when I set the loading over to true, I can just keep that other stuff the same. I don't have to keep like resetting the username. I can only pass in, or I can choose to only pass in like the fields that I want to change, such as loading here. And then those other ones will just copy over from what it was previously. Okay, so that's generally how the refresh works. And to kind of get the idea of how to like code on top of this, I have like one to do here that basically says, okay, so add a property that disables the refresh button whenever we are loading. So you can see here that the refresh button here is still active the entire time. And so I guess a bug kind of that I can showcase is that if I just spam the heck out of the refresh button, like weird stuff will happen. So I guess it wasn't that weird, but nonetheless, I shouldn't be able to spam this button. And it seems to cause like additional loads sometimes. It seems to cause one additional load. The idea is though that I should probably tell the screen that whenever I am loading, the um, the refresh button here should be like disabled. So I guess there's sort of two ways you could think about doing this. So if we go back into the screen here, a very like raw way to do this, like that's perhaps not like the greatest practice, is to do some app logic inside of the screen itself to say for this button here, this is the refresh button. So enabled is like how you to turn a button from like clickable to unclickable, and it also visually reflects that. Well, my AI autocomplete is too good. So basically, we could say that the refresh should only happen when it's like loaded, so when it's not loading. So I can say something like UI state dot like not loading. And this will work like also completely fine. So if I rerun this, so the Zoom thing is blocking me. It's annoying. If I rerun this, then you'll see that this works fine. Totally fine, in fact. And if I go to the screen here, you can see that the refresh button here, when I'm loading now, like grays out. And then once the loading stops, it now grays like back in, and so I can click it again. The idea, like why this might like technically not be the best idea is perhaps the refresh like perhaps the refresh button here, like you might want to add like additional more complex logic for this. And so what's perhaps like a more robust way, like a more complicated, but like slightly more complicated, but more like I guess allows for more functionality, is if you make like a property here that disables or re-enables the button. And I can show an example of how to make this more like useful in a second. To make like a derived value to say the refresh should be enabled whenever I'm not loading. And then instead of using this like because this is technically like a logic computation. It's the screen kind of deciding for itself that like, oh, I think I should be enabling this button whenever I'm not loading. You can make it like you can make the screen like even dumber by just giving it directly with this refresh enabled button or this refresh enabled field instead that's like doing that computation for it. Again, it's like it's something as small as like just saying like not loading. But even something as small as that is something that like best practices wise you might want to still do in the view model. And this also has the same effect again of whenever I'm not loading, the refresh button is enabled. Why this might be useful is, and I guess I can just sort of wing this now, but let's say, for example, that I also wanted to add like this property that's like, oh, it should be like waiting 5 seconds after the last load or something like that for the loading to occur. Um, I can add some sort of like property like this that's like, oh, waiting refresh. That's like, oh, it's still waiting a little bit for the refresh and should only enable after like a certain amount of time has passed, for example. Let's set that to false immediately. And then let's say that the refresh enabled should only be happening if it's not loading and it is not waiting or like not in this delay period. And then we can have it in this on refresh such that like, well, the new transactions just loaded at this line of code here is like 73 that I made. The new transactions have just loaded, but let's say I want to wait like 5 seconds before re-enabling that button. Then I can use like delay, which basically waits 5 seconds. And then instead of like changing other stuff, I can use this like waiting refresh. And we'll say, or we'll set that to true initially. And then after 5 seconds of it loading or having loaded, we will set that back to false. Okay, so I hope I didn't mess like the Boolean stuff. I think that seems correct. But hopefully, anyways, when I run this, let's see, it should wait 5 seconds and then re-enable the button, which I think is what it'll do. So let's see, loading here, waits 1, 2, something seconds, and then refresh enables again. Oh, the animation looks a little weird. I could have tweaked the screen to not make it do that, but ignoring that, now once I refresh, it'll wait a couple of seconds. And then now, after 5 seconds, the refresh button will appear. The animation looks weird because I didn't account for that, but basically I'd want to use dot loading here instead of the UI state. But regardless, this is what like one example of what like using this other value could be useful for if you wanted to implement more complex logic, which this is not something that you'd be able to easily do in the UI at all. There's like it's much more complicated in the UI to be like, oh, whenever the loading changes, I need to wait 5 seconds. Something like doing like that kind of computation in the UI is a lot more complicated. And so handling those kind of complex things in the view model is a lot more simple. Okay, so that was a bit of like a winged demo at the end there, but any questions on anything I just did or how any of this bank stuff fits together between the view model and the screen?
There's a question in the chat.
Oh, question in the chat. Sure thing. What's at inject? Good question. Don't worry too much about how this stuff is working. This is using a third-party library called Hilt. That's why it's called the Hilt view model. It's using a third-party library called Hilt to manage like where this like view model, since the view model is a class and like an object of its own, Hilt is a library that manages like where that view model like lives in the Android lifecycle. We'll go over how to like set this up, or we'll just set it up for you in future assignments so you don't have to worry about that. In general, though, this at inject thing like allows you to make different objects in Hilt like depend on other ones. Again, this is not something you'll have to do for like A4, but we'll get to it in like week 6 with networking, where bank repository is like our networking stuff. And so if the view model needs to network, it will inject that model or like we'll inject that model into the view model here so that the view model can network with like bank repository call stuff. Good question, though. We'll get into that more in like week 6, so don't worry too much about it. Okay, any other questions? If not, or I guess in the meantime, I will flash the lovely attendance form. Maybe what you've all been waiting for. But yeah, if there are any other questions, you can let us know. We'll stick for a little bit after class, and we'll also take a look at the Zoom chat if anyone has anything extra. But otherwise, that's all we have for today. So thank you all for coming. Let me know if there's any issues with the form. But other than that, that's all we have for today. So thank you all very much for coming. I hope you enjoyed your spring break and hope you're getting ready to start Android dev once more. Yay.